Page 55. Okay, I'm looking at the right hand side first. Well, I guess we're going to do the left hand side. All right, if b is a real number and f and g are continuous at x equals c, then the functions listed below are also continuous. Okay, if b is a real number, so here's b is a real number, and if f is continuous at x equals c, if you multiply that function by a number, then it's continuous. If f and g are continuous, if you add or subtract them, they're still continuous. Or if you multiply the functions, they're continuous. If you divide the functions, they're continuous except when the denominator is 0. Right? So the denominator can't be 0 for it to be continuous. All right, so based on that idea, polynomials, this is continuous for all real numbers. Okay, this is all real. This is negative infinity, infinity. That's polynomial. Rational functions, okay, so rational functions look like this, f over g. So g cannot equal 0. So the denominator cannot equal 0. All right? And radicals. Radical, so let's say f is under the radical. F of x has to be greater than or equal to 0. The inside of the radical has to be greater than or equal to 0. Trigonometric. Rewrite all of them, so rewrite any trig function in terms of sine and cosine. That's not a division. I'm just writing, maybe just put comma sign. Sine or cosine. Okay? And then identify the denominator. Then the denominator does not equal 0. Right? So example, tangent x. Right? If you rewrite tangent x as sine and cosine, so tangent is not continuous when cosine x equals 0. Exponential is continuous for all real numbers. And if you have a log, so log base, I don't know, a, and I have a function in there. So the function has to be greater than 0. All right, that's it. Yeah, and we're not going to do the intermediate value theorem today.